ating specific speed, kung paano natin ginagamit. At ngayon naman, po-proceed na tayo sa ating pumps. So when we say pumps, pumps are essential industrial equipments as they play a pivotal role in pushing liquids or gases from one location to another. Therefore, it is crucial to understand the basic pump design to ensure that they can operate effectively and efficiently. Oy, 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 oy. Nasaan yun? One moment po. So ito namang pumps, sa pag-usapan naman natin yung pumps last time na. So intro pa lang, so pinag-usapan na natin yung pumps. Nadagdagan lang natin na information or mas pinalalawak lang natin yung ating discussion for the pumps. So pumps typically consist of three main parts, a housing, an impeller, and a motor. So the housing is the pump's main frame which supports the impeller, then contains the pump fluid. The impeller, yun yung ating rotating motor na kahapon tinawag natin bilang rotor po, no? Helps move the fluid through the pump, and finally the motor that provides the power needed to rotate the impeller and create suction. Ito naman po si motor, siya yung nagbibigay ng rotational motion or rotational energy papunta dun sa ating impeller or yung ating rotor, kasi propeller pag axial naman yung pinag-uusapan natin. Bakit nga ba natin kailangan na alam kung paano mag-design ng tamang pump? Kasi daw po dahil dito sa limang bagay na to na pwedeng lumabas sa midterm exam nyo. No. So designing a well-functioning pump can save you time and money in the long run. A well-designed pump can minimize the downtime and increase productivity. And a good pump design can improve efficiency of your operation, leading to lower energy costs. At kapag daw po tayo ay naglalagay ng pump sa ating mga planta or sa isang system, lagi higit sa dalawa yung ini-install natin kahit isa lang yung kailangan natin. Kasi for example, si Pogi, no, si si Ponce, si Angelo, ay ginamit natin ng 24/7, di kayo masisira agad si Angelo. Ganon din yung ating pump. So si pump dapat po may kasalitan. Hindi po siya pwedeng gamitin ng 24/7. No, pero kapag jowa, dapat isa lang. Pero kapag pump, dapat dalawa or higit pa. Kasi kailangan meron kasalitan. For example, nagme-maintenance tayo, papalitan natin ng isang pump naman. Pag naman gagana, siguro every 3 hours, every 4 hours, palitan sila. Kasi yung pump natin, dahil siya ay rotating, dahil sa so much rotation, nag-create din siya ng heat at frictional energy na nakakasira sa mismo nating impeller. So proper pump design can help reduce wear and tear on the pump parts, extending their lifespan. Getting the pump design right can create a safer work environment by reducing the risk of accidents and injuries. So meron daw po tayong iba't ibang parts ng pump, maliban sa tatlong major parts na ating tinatawag na housing, impeller, and motor. So may iba pang parts ang ating pump. Nandyan yung ating impeller, shaft, casing, sealing, bearing, coupling, suction nozzle, discharge check valve, strainer, at tsaka marami pang tayong tinatawag na fittings. At para dito, I have here a sample video for the parts ng ating pump.
Welcome to hardetengineer.com. I am Varun Patel. In this video, I am going to explain you about centrifugal pump parts. In this video, I am covering 9 parts such as body, which is also known as casing, impeller, weir ring, shaft, coupling, bearing and bearing housing, sealing system, suction and discharge flanges, and support frame. So, watch the video to get the complete understanding of this topic. And don't forget to subscribe because that way you will get the notification of my future video. You can subscribe right now by just clicking the subscribe button on the right hand side of your screen. So let's start with video. Pump is a mechanical product. It is made of several different parts. Based on the type of pump, it may have a different parts. Here I have covered the most commonly found centrifugal pump parts that you may found in almost all pumps. Here in the exploded 3D model, you can see the different parts of the pump. This is the simple pump that is used in the water application. I have marked the main components here. So let's start with the first part of centrifugal pump. Body and casing. Pump body, which is also known as casing, is the largest component of the pump. It can be fabricated or made from casting. Most pumps that you will see in the process plant have a cast body. Forged or fabricated casing is used for the special application pump where casting is difficult or costly. Body hosts all other components of the pump. It will also provide the passage for the fluid. The volute design of the body helps in the increasing the pressure head by converting energy. Depending on the pressure and the fluid property, it can be manufactured from the different materials such as carbon steel, stainless steel or alloy steel. There are different types of casing design available to meet the different pump design. The first one is single and double volute body. Here in the photo, you can see the single and double volute casing design. Pump with large radial force use double casing body to reduce the force on the body. Second is single and double suction body. Here in the photo, you can see the single and double suction casing design. In double suction design, fluid can enter from the both side of the impeller. This is more complex than single suction design. The third type is single or multi-stage body. As you can see in the photo, multi-stage pump body is bigger and costly than the single stage pump. The next is radial or axial split body. Depending on the pump type, whether radial or axial, the pump body can be manufactured accordingly. In the photo here, you can see the both type. Now,
Hello guys, so pabanter lang ng konti si Sir na may dadagdag lang si Sir na information tungkol dun sa nabanggit kanina. So pagdating natin po dito sa tinatawag nating single suction at double suction pump. So let me just go back here. Naglo-loading lang po, pasensya ng mga
casing design.
Yan. Pag
In
sinabi po
double
natin
suction
single
design,
suction at double suction, ang tatandaan natin pag single suction, Chico, ano nga ba pag sinabi nating suction? Ano ibig sabihin ng suction, Chico?
Hello po, sir.
Hello pare, pag sinabing suction, anong naiisip mo?
Ano po, pag po sanction ni
Suction,
Yung-
hindi sanction na, suction.
yung ano po, yung
Nagsasak.
Opo, ng mga po, liquid or po, yung mga hangin po sa pump pressure
Sa
po.
Tagalog,
Paano? Para pong daluyan.
daluyan. Pag sinabing suction, okay, thank you so much, Chico. Pag sinabi nating suction, nahigop, no? Nahigop o at pag sinabi nating single suction naman, isa lang po yung pinaghihigupan niya ng tubig or ng fluid kung siya man ay gases or isa lang po yung pinapasukan ng fluid. Pero pag sinabi po nating double suction, dalawang side yung pinapasukan ng fluid. Habang pinapasukan sa harapan, ay pinapasukan din siya sa likuran. no, habang hinaharapan siya ay nililikodan din siya. Sabay pumapasok yung fluid natin. Ibig sabihin, dalawang fluid agad yung naiimparta natin ng energy. Ganun po kapag single at double suction. Pag sinabi naman po nating multi-stage, okay, si multi-stage ito yung nadaanan nyo na nung tayo nag-termo 1, termo 2. Si multi-stage, yung pag isang stage lang, pag single stage, pagpasok ay increase ng energy through impeller, paglabas o di mataas ng energy. Pero pag multi-stage, yung ipinasok kay impeller 1, ilalabas ni impeller 1 at siya namang papasok kay impeller 2. Yung inilabas ni impeller 2 ay ipapasok kay impeller 3 at yung inilabas ni impeller 3 ay ipapasok kay impeller 4, so on and so forth, hanggang kung ilan yung stages na meron tayo. Ibig sabihin, habang pumapasok, tumataas ang nadadagdagan ng energy na naibibigay natin into the fluid, my friend. Alright, so let's now proceed with our impellers po.
Now the next part of the centrifugal pump is impeller. The impeller is the most critical part of the pump performance. Proper impeller design and selection will decide the efficiency of the pump. It transfers the energy from the driver to the fluid. It converts kinetic energy into pressure out of the pump. Impeller has a curved blade, which is also known as a van, and it is mounted on the pump shaft. There are three basic impeller designs available. Here you can see the same in the images. The first one is open impeller, second one is semi-closed impeller, and the third one is closed impeller. So open impeller, it is the most simple design. The vane of this type of impeller is open on both sides. Due to this design, it is structurally weak as compared to other two types. The open impeller is used in the service with particles. You can also see this type of impeller in a cheap low-duty pump.
All new Jollibee Burger Steak. Bigger patty, more sauce. 70 pesos lang.
Sarap.
Second type of
Yes,
pump
Ivan.
impeller is semi-closed
Napindot.
Wala. Pag nag-raise na nga din na order ng Jollibee.
impeller. In this design, one side of the impeller van is attached with a circular disc. This impeller is stronger than the open impeller and provides better performance. This impeller can handle liquid with some particles without choking. Now the third type is closed impeller. Pump used in the process plant have a closed impeller. In this type, vents are enclosed from both sides. In the image, you can see this type. A closed impeller is difficult to manufacture and costly. It gives the best performance and high efficiency. It is used with clear liquid and cannot be used in the liquid with suspended particles. The next pump part is wear rings. You can see the wear rings used to prevent damage to the impeller and pump body in the image here. It is a metal ring as you can see in the image. The wear rings function is to protect costly impeller and body from the damage due to the high speed. You can replace these rings at periodic maintenance. The next part is shaft. The function of the pump shaft is to transfer the driver energy to the driven, that means impeller. It is forced drill with machine surface. Depending on the pump design, it can be overhang type such as in a single stage and suction pump, or supported at both ends such as between bearing pump. The next part is coupling. To connect pump with a driver, whether it is motor, engine or turbine, the coupling is used. There are two types of pump coupling used in the pump. The first one is fixed or rigid coupling. This type of coupling is used when you have a perfectly aligned driver and motor. It is not suitable for the most pump used in the process plant. If there is a misalignment, it will create a high stress in the staff. The next type is flexible coupling. It is regularly used in a pump as this can compensate some of the amount of both radial and axial misalignment. In the image here, you can see the both type of pump couplings. The next is bearing and bearing housing. Most centrifugal pumps use standard roller bearing. The bearing function is to keep the shaft in position, and it facilitates the frictionless movement of the shaft. Bearings are also one of the most critical components of the pump, as improper selection leads to pump failure. Bearing housing is the place where bearings are installed. Lubricant is filled in this housing to keep bearing cool and well lubricated to achieve the best performance. In the image, you can see the bearing and bearing cover under which bearing sits. Next is the sealing system. The function of the sealing system is to prevent the leaking of the liquid from the pump. Depending on the properties of the liquid being handled, complexity is involved. The pump sealing system can be a simple and a complex at the same time. A simple gland packing is enough for the water pump, whereas for toxic or inflammable liquids, a separate sealing system is required. Different type of mechanical seals are available to meet these requirements. The next part is the suction discharge flanges. Suction and discharge flanges are the part of pump body. It can be end suction.
Hello, my friends. The one that is being discussed is flanges. When we say flanges, it is the one that is being connected to the inlet pipe and outlet pipe. So the flanges is this circular thing with these four holes. That is what we call flanges. That is connected through bolts and screw, my friend. Okay. But when we say suction nozzle, the whole discharge and suction part, that is what we call as the nozzle. The flanges is only the one that is connecting the pipe to the pipe inlet and outlet. Okay, let's continue.
Top discharge or radial type. Dimension of these flanges are machined to match the connecting pipe flanges. Sometimes you can see the small ring welded inside the discharge flange to achieve the desired flow rate. The last part of the pump is a support frame. Pumps are mounted on the structural support frame. This frame provides the base for the pump and driver. Proper design is necessary to avoid the vibration of the pump. For some engine-driven pump, drivers are installed on a separate frame. The frame is constructed from I-beam and channel to provide strength. This is all about centrifugal pump parts. If you want to learn
And that is for the parts of our centrifugal pump. So meron din po tayo dito, other parts din naman po yung nasa ating module. No, super dami po ng nagiging parts fixture ng ating pump, pero that is the basic, no, basic parts. So again, the impeller, that's the heart or the most important and central part of the pump design. Yung shaft natin siya yung nagdudugtong sa ating pump at kay motor. Yung casing natin siya nag-house ng lahat ng internal component ng ating pump. Si sealing naman po siya yung nagpe-prevent ng leakage ng fluid entering or ng gas entering to the impeller going to the motor. Then bearing naman po, katulad nung sa mga bike at sa mga sasakyan, naglalagay tayo ng bearing para ma-reduce o maiwasan yung wiggling motion dahil meron tayong rotating element. Si coupling naman po siya nagdudugtong sa shaft, papunta kay impeller, papunta kay motor. Suction and discharge nozzle, katulad doon na banggit ko kanina. Then check valve naman po at strainer. Si check valve po, ginagamit natin para maging one-way flow lang po yung ating fluid at hindi po siya babalik. Pag strainer naman po, lalo kapag closed impeller ang gamit natin, bawal ang solid particles, gumagamit tayo ng strainer para ma-ensure na walang solid particles na magpe-penetrate or magka-pass through sa ating pump. Kasi pag nagkaroon niya ng solid particles, masisira yung vanes, masisira yung ngipin ng vanes, or masisira yung mismo impeller. Pagdating natin kay positive and rotodynamic machines naman po, they are already discussed yesterday. So here we have types of pump. For the types of pump po, so we have the basic types of pump. So nandyan yung centrifugal pump, reciprocating pump, at yung ating rotary pump. Pag sinabi nating centrifugal pump, ito ay na-discuss na ni Sir no introduction pa lang. Centrifugal pumps, as the name implies, employ centrifugal force to lift liquids from a lower to a higher level. So this type of pump in its simplest form comprises an impeller rotating in a volute casing. The liquid led into the center of the impeller is picked by the vanes and accelerated to high velocity by rotating the impeller, and the discharge by the centrifugal force into the casing out of the discharge. When the fluid is forced away from the center, it's called the eye, the impeller vacuum is created and more liquid flows in. Consequently, there is a constant flow through the pump. At para mas ma-appreciate nyo yung kanyang working principle, so I have here a sample video po.
Pump working. Centrifugal pump working. Centrifugal pumps pump liquid by means of the centrifugal force developed by rotation of an impeller. The kinetic energy imparted to the liquid by impeller rotation is converted to potential energy by making the liquid to flow through a volute casing in volute pumps, a diffuser in turbine pumps. For explanation, the centrifugal pump representation above shows both guide vanes and the volute. Let us understand the basic stages through which the liquid is pumped. Liquid enters the pump through the inlet connection and enters the impeller. The impeller rotates and imparts energy to the liquid and delivers it at a higher velocity to the diffuser. The vanes of the diffuser are tangential to the impeller. In the diffuser, the velocity energy is converted to pressure energy. The volute completely surrounds the diffuser and serves to collect the liquid and to recover additional velocity energy. The liquid is then expelled through the discharge. Having understood the basic principle, let us view the flow of liquid through the 3D model of 1. A volute pump, 2. A turbine pump. Volute pump. Shown aside is a model representation of a typical volute-type centrifugal pump. The casing has been split open to view the internals. Depiction shows liquid entering the pump at the impeller eye. As seen, the rotating impeller vanes impart kinetic energy to the liquid. This kinetic energy is converted to pressure energy as the liquid is directed along the volute to the discharge. Turbine pump. A model representation of the impeller, diffuser and the casing of a typical turbine pump is shown. As seen, the casing is not of the volute type. Let us observe the flow of liquid along 2 stages of pumping. The liquid is centrifugally forced outward by the impeller. It is then guided along by the diffuser and the casing and enters the impeller eye of the next stage of the pump. Across each stage of pumping, the kinetic energy imparted to the liquid by the impeller is converted to potential energy along the diffuser. Liquid at a higher pressure now enters the impeller eye of the 3rd stage and so on. This process is continued across all the stages of pumping and finally the liquid is led to the discharge. The description is a simplified extract from the centrifugal pump training course developed by SCN Graphitek. The actual tutorial provides much more detailed explanations with a large amount of interactivity. The training course covers the basics and principles, API 16 types of pumps, and includes a pump troubleshooting guide. The tutorial exclusively focuses on multimedia inputs like graphics, animation, interactivity.
Alright, and that is for our centrifugal pump, no? So that's the operation. Also for the impeller po natin, meron tayo dito yung single-sided at katulad sa example sa video yung ating double-sided impeller at meron din po tayong tinatawag na shrouded. Also, here some features po. Bakit nga ba natin pinipili at bakit natin ginagamit ang centrifugal pump? Kasi si centrifugal pump daw po ay simple. Also, si centrifugal pump po ay low cost dahil marami na po ang nagmamanufacture at siya po ay commercially available as well. Also, ability to operate under a wide variety of conditions. A variety of conditions adapted to operate under practically any head up until several thousand feet. So, yeah, several thousand feet. Then also will handle liquids at most any temperature up to 1000 degree Fahrenheit. With this one also adapted to operate at speed that are standard for electrical motors. Also, the flow from the pump is continuous, that its discharge can be throttled without the pumps building up an excessive pressure or overloading the driving force or driving unit. So we have also different types ng centrifugal pump. Pero pag tinanong natin, sir, ilan po ang types ng centrifugal pump? Marami din po. Dahil for example, centrifugal pump siya pero gagawin na gamit ng ibang material o gagawin na iba't ibang head depende sa pangailangan na nagiging specific yung kada isang centrifugal pump kaya dumadami yung uri or yung type natin ng centrifugal pump. Here, so, we have the volute type, the diffuser type, mixed flow propeller or axial. Si volute type, yun yung pinakita kanina sa inyo sa video. While si mix at si propeller, ito naman yung dinrawing ni Sir sa board. Si mixed flow, yun yung ating centrifugal pump na dinrawing ni Sir, pumasok sa x-axis, lumabas sa y-axis. So, for diffuser type naman, so this is the diffuser type. Let me share this one. So this is our diffuser type, peripheral centrifugal pump. I'm sorry. So diffuser type centrifugal pump. So kung mapapansin nyo, para lang po siyang simpleng centrifugal pump pero ang pinagkaiba, kita nyo tong violet part na to. So itong violet part na to ay nagpapakita na yung ating pong pump ay may additional guiding vanes or tinatawag natin bilang diffuser. Para paglabas po ng fluid, marireduce yung turbulence niya. Then, siya po ay magdidiretso doon sa gilid. No, let's see this one kapag pumasok yung fluid natin. Meron ba dito? Ayun lang pala yung ano niya. Ayun. So, this is our diffuser type centrifugal pump. Then, for our volute centrifugal pump, nandyan yung ating pinag-usapan kanina, yung single suction at saka double suction. At pag yung multi-stage ay yung maraming impeller na nakalagay. Then, we also have other types ng centrifugal pump. Nandyan yung condensate pump, close-coupled pump, non-clogging pumps, paper stock pump, pumps for handling abrasive material, packing less, chemical, glass pump, hot oil and high pressure pump, Rennet pump, pneumatic sponges, and some pumps. Also, meron din tayong tinatawag yung ating ram pump. Nagagawin nyo po o ipe-perform nyo this coming Friday, September 12. No? So, for additional information, so this will be the principles behind a ram pump po.
I made a video a while back about water hammer, a hydraulic phenomenon that can lead to major problems in pipelines. Then I did a video on steam hammer, a somewhat related phenomenon associated with steam piping systems that can be extremely dangerous. And then I did a follow-up to the water hammer video talking about transient vacuum phenomenon that can collapse pipes if they're not designed and operated correctly. But even after those 3 videos, it turns out I haven't told the full story, because even though water hammer is generally a problem for engineers, it turns out there's a way to take advantage of this normally inauspicious effect for a beneficial use. Hey, I'm Grady, and this is Practical Engineering. On today's episode, we're talking about hydraulic ram pumps. This video is sponsored by NordVPN. Visit nordvpn.com/practicalengineering to get 81% off a 3-year plan. More on that later.
Sa Sigurado. Sa Shopee Mall, ang prices lower than SRP.
Shopee Mall?
Sigurado sa Shopee Mall!
Sigurado sa Shopee Mall.
Ang CDO Corner Norte, siguradong beefy.
Lunch na
Bili
daw,
na,
mag-CDO.
Mommy.
A hydraulic ram is a clever device invented over 200 years ago that can pump water uphill with no other external source of power except for the water flowing into it. No, it's not a free energy device, but if you search around, you'll find lots of great implementations of this style of pump on YouTube, mainly from people doing homesteading and off-grid lifestyle vlogs. And it's easy to see why ram pumps have such popularity among these groups. Because if you've got a piece of land with an abundant source of water, a ram pump lets you get that water to a tank or a location at a higher elevation with a really elegant design that requires no electricity or fuel and only 2 moving parts. So of course, I built my own so you can see how it works. But first, we need to build just a little bit of foundational knowledge on the behavior of fluids, and this is something anyone can understand. There are 3 types of energy that a fluid can have, and in civil engineering we normally convert them to their equivalents as the height of a static column. This distance is called the head. Understanding the energy in a fluid is how we solve a lot of engineering problems, because in most scenarios, the amount of energy stays the same, and the only thing that changes is what form it takes. The first type is head from gravitational potential. It doesn't have an equivalent static column because it is a static column. The head is just the distance from an arbitrary datum. This one is easy to understand with a tank and a tube. I can move this tube around wherever I want, but the level in the tube and tank are always going to be the same. They're both exposed to atmospheric pressure at their surface and they're not moving, so there's no velocity. It's just pure gravitational potential. The second type of energy is pressure head. In this case, the head is the pressure divided by the gravity times the density of the fluid. So if I close off the top of my tank and add some air pressure, the level in the tube goes up. The new height is the pressure head, the equivalent static column related to the pressure in the tank. For a given pressure, a denser fluid like mercury will have a lower head compared to a lighter fluid like water because they have different unit weights. A good example of measuring pressure head is a barometer. We live at the bottom of an ocean of air, and we like to keep track of the air pressure down here. One of the easiest ways to do that is to measure how high up the pressure can push a static column of fluid, in most cases mercury.
Sa Sigurado. Sa Shopee Mall, ang prices lower than SRP. Sigurado sa Shopee Mall!
The final type of energy is velocity head, which relates to a fluid's kinetic energy. The conversion for velocity head is velocity squared divided by 2 times the gravitational acceleration. I can demonstrate the equivalent column of water using a tool called a pitot tube. That's a lot of background, but it's important in understanding the function of a ram pump, because without an external source of power, even though you can go from one type of energy to another, you can't get more energy out than you had at the start. For example, I can convert a static column of water to one with some velocity, but I'm never going to get the fluid to a higher elevation than where it started, with one exception. An exception that the hydraulic ram pump takes advantage of beautifully. A ram pump is essentially just 2 one-way check valves, one called the waste valve and the other called the delivery valve. To get it started, you just momentarily open the waste valve to allow water to flow. After that, it's working on its own to pump the water uphill above the elevation of the source. Pretty amazing, I think. Let's walk through the path of the water to understand how it works. First, as the waste valve opens, water flows into the pump and immediately out the valve. But as it picks up speed, the flowing water eventually forces the waste valve to slam shut. Now the water is stopped in the pump. It had kinetic energy, but now it doesn't. That means the kinetic energy was converted to something else, in this case, pressure. This is the definition of water hammer. Slamming a valve shut converts all the kinetic energy nearly instantly, creating a huge spike in pressure that can lead to stress and damage in pipe systems and connected equipment. In the case of the ram pump though, that spike in pressure has a different effect. It opens the second check valve and forces water entering the pump into the delivery line. As you can see from my digital pressure gauge, this process is cyclical. pumping some of the water and wasting the rest each time the valve slams shut. You can see what's happening here in real time. The pump is robbing some of the kinetic energy from the flow and imparting it to a smaller volume of water. It's a redistribution of energy, converting low head and high flow into high head and low flow. And this type of pump can really create a lot of head. I ran my discharge line up to well above the roof of my shed, and my pump is still able to get the water up there. Sometimes an air chamber is included in the pump to smooth out those sharp spikes in pressure and provide a more even flow rate out of the delivery pipe, reducing wear and tear on the pump components.
Sa di sigurado, sa Shopee Mall, ang price is lower than SRP. Sigurado sa Shopee Mall!
Still shopping on other malls? Get real on Las Mall.
If you think in terms of modern electrical devices, imagine we installed a hydropower turbine on a pipe to spin a generator and then use that electricity to power a pump to move the water coming out of the turbine. Obviously, you wouldn't be able to pump all the water, and anyway, that would be a pretty complicated setup for something the RAM pump can do with a few very simple off-the-shelf plumbing parts. In fact, there is a type of pump that works from a water-powered turbine. Maybe I'll build one of those next. For now though, I think the RAM pump is an ingenious way to take advantage of the properties of fluids. We all need water for a variety of reasons, so being able to move it where we need it without any fancy equipment or external sources of power is a pretty nice tool to have in the toolbox.
Alright, so that is your RAM pump, no? So si RAM pump, siya yung principles na gagamitin natin sa, I'm sorry. Open, ano na ba ako? Ayan. So si RAM pump, yan yung inyong gagawin on our face-to-face meeting sa darating na Friday. And I will be creating a letter to GSO for us to be able to use the water supply from here at Batangas State University, no? At saka para makipagpaalam na rin tayo ng location. Possible location natin ng pagpa-performan nyo ng RAM pump ay dun sa likod ng canteen, para wala namang damo na magdadamusak, o at least kapag doon damusak na, so hindi na tayo mamomroblema. So I think that would be all for now. Any question po for our first half of chapter 3? Question para sa first half ng ating chapter 3? Question, clarification? Anyone? Hello po.
Wala naman po siya.
Wala naman po
Wala
yata, sir.
So the remaining time, I will be giving it to you para makapag-prepare, makapag-usap para sa gagawin nating RAM pump. No. So everyone, you are all present today. Hindi na ako mag-attendance para kayo ay makapag-usap-usap na by group. If you want, you may have your own meet or pwedeng sa mga GC nyo na. No, thank you everyone, and I do hope you have a great week ahead. Bye-bye mga idol, and see you next week. Love you po.
Love you to sir.
Thank you, sir.
Thank you po.
Thank you po.
Thank you po.